Hello everyone, I'm Mohammad Jawad Arfin and I am from Group 6. Today we are going to present our final presentation on CSE 332, which is mainly about computer architecture and organization. Since it's a group project, I have a team too. My teammates are Mohammad Taibur Rahman Rishad, Mohammad Wasiul Islam, and Senoba Mustafa. We were given three projects. Out of three projects, we choose project A, where we are instructed to design a 16-bit arithmetic logic unit from scratch with the help of control unit by following the ISA format. And secondly, we were also instructed to show at least two logical instruction and arithmetic instruction. Here we used a control unit, a 16-bit logic unit, registers, and data path. From now on, my teammate Mohammad Wasiul Islam is going to take over from here.
Thank you. Here we can see a arithmetic logic unit. Here there are two arithmetic and two logical operations used here. And sub are from arithmetic, and the and or are from logical operation. Thank you. From now, Sanaba Mustafa will continue.
Thank you, Wasiful Islam. So here we can see a design of a control unit using 4-bit opcode. In this opcode, we have used both arithmetic operation and logic operation with a certain fixed value for each operation, with which we will get 4-bit of outputs. So now we can see here, for for add operation, the fixed value of opcode is 0000. For subtract operation, the fixed value of opcode is 0001. And for AND operation, the fixed value of opcode is 0010. For OR operation, the fixed value of opcode is 0011. Using this opcode value, we will get a register write enable, B invert, C in, and ALU loop operation. So in register write enable, the result of operation from ALU is stored. In B invert, we get 1's complement of B. In C in, we get 2's complement of B. These two are basically used for subtraction. For ALU loop, we will get the result of 2-bit operation in order to form 2 to the power 2 combination. Thank you. From here, my teammate Taibur Rahman will continue.
Thank you. Here we are instructed to show two arithmetical operation and two logical operation. First we do additional instruction. In addition, we store the value of R1 and R2 register in R3. Here we store 2 in register number 1 and 1 in register number 2. Then in data path ROM, we put the value 0 for addition operation, then the register number where we store the addition value, which is register number 3, then the register number 1 and 2. Lastly, we use clock pulse to store it. Now let's see the stored value, where we got 3 in register number 3. To justify the value, we do manual calculation, where we can see the binary value 11, which in decimal is 3.
For our second arithmetic instruction, we will do a subtraction. The value will be 1 and 2, and we will register the value in R4. In the opcode, we will use 1 for subtraction, and we will save the value in R4. So we will use 4, and the initial value is 1 and 2. After that, we will use a clock pulse, and we see the result in R4. So we can see the result is 1. For the justification, we can see the value of 2 is 1 and 0, and value of 1 is 0, 1. By the subtraction, we can see the value is 0, 1, and the decimal value is 1. So it is 2.
For first logic instruction, we have used AND gate operation. So basically in AND gate operation, we will do operation for register 1 and register 2. And we will store the value in register 5. So here in the data part, the opcode value for AND is 2. So the value will be 2512, where 2 is for opcode, 5 is for store value, 1 and 2 are the register value. By giving a clock pulse, we can see the result is 0. So for justification, we see by doing a manual calculation, the binary value is 00 in decimal, which is also 0. So it is justified.
Here for the last instruction, we're going to do an OR operation. So we're going to do an OR operation of register 1 and register 2 and store it in register 6. So here the opcode of OR operation is 3, and as we're going to store the result in register 6, the next value will be 6, and we're doing the OR operation of register 1 and 2, and the next two values will be 1 and 2 respectively. And if we so we have to do a clock pulse to store the result. Now if we go to data path, we can see the output result as 3 on register 6. To manually justify the result, we're gonna do a manual calculation, and using the truth table, we're gonna find out the result of the OR operation. So here we can see that the result is same as the data path. So this is a successful outcome. So basically, if we summarize our whole project, in the first part, we did build a 16-bit arithmetic logic unit from scratch using the help of control unit by following the ISA format. In our second part, if we did arithmetic instruction and logic instruction, and we justified the result using manual calculation, and we did got the same result, so we can say that our whole project was a successful outcome. And that's it. Thank you all.